Welcome to The Explainer. Today, we're going to break down one of the most powerful and, honestly, misunderstood concepts shaping our world, the algorithm.
And to really get a handle on this, let's not start with the past. Let's jump ahead and look at the near future. Okay, so picture life in, say, 10 years. You're probably thinking of self-driving cars jamming the streets, maybe drones dropping packages on your doorstep. And yeah, that stuff is coming. But the biggest change, it isn't going to be the hardware you can actually see and touch.
The real revolution, the one that's going to change everything, it's happening behind the scenes. The way we talk, the way we shop, how we work, even how we get from A to B, it's all being completely reshaped by the crazy fast improvement of these algorithms.
All right, so what is an algorithm, really? Let's bust a myth right now, because it's not some mysterious, magical spell.
At its heart, an algorithm is just a set of step-by-step instructions for solving a problem. That's it. And this idea, it's not new at all. I mean, we're talking way before computers. This stuff goes back thousands of years, to ancient Greece, even Babylon.
Here's a great way to think about it. It's just like a recipe for a cake. You've got your inputs, right? Flour, sugar, eggs. You follow the instructions, mix this, bake for that long, and you get your output, a cake, hopefully a delicious one. An algorithm is the exact same thing. It just uses data instead of ingredients.
Okay, to really see how this works, let's do a little time traveling. We're going back to ancient Greece to solve a puzzle that's actually surprisingly practical. So imagine this. You've got a big courtyard, 38 by 16 feet, and you want to tile it with the biggest square tiles you possibly can. The catch? They have to fit perfectly. No weird gaps, no cutting tiles. So what do? Well, the Greek mathematician Euclid came up with an algorithm for this exact problem way back around 300 BC, and we can walk through it right now.
Okay, step one. You look at the shorter side, which is 16 feet. So the biggest squares you can fit in are 16 by 16. You can lay down 2 of those. Great. But now you've got this leftover rectangle, a 6 by 16 foot piece.
And here's where the magic of the algorithm kicks in. We do the exact same thing again, just on that leftover piece. The shorter side is now 6 feet, so we put down 2 6 by 6 tiles. And yep, that leaves us with an even smaller little rectangle.
You see the pattern here? The process is always the same. What was left over before is our new problem to solve. So now we've got a 4 by 6 space, we fit one 4 by 4 tile in there, and we're left with just this tiny 2 by 4 foot strip.
And we're at the final step. That 2 by 4 foot area? It can be perfectly filled with 2 2 by 2 tiles. Boom, no remainder. We're done. And that means the algorithm has found the answer. That last tile size we used, the 2 by 2, that's the biggest tile that will perfectly cover the entire courtyard.
So here's what that looks like in pure numbers. See how the remainder from each step just becomes the new divisor for the next one? You just rinse and repeat that process until you finally hit a remainder of 0. And that last number you use to divide, in this case 2, that's your solution.
So there it is. The answer is 2 by 2 foot tiles. See? No magic involved. It's just a simple, logical process that you can repeat over and over again.
Okay, that's cool for an ancient Greek courtyard, but what does that have to do with today? Well, let's see how this exact same step-by-step thinking scales up to solve some incredibly complex, modern problems.
The basic idea, the core logic, it's exactly the same. But the scale? Whoa, it's on a completely different level. That simple courtyard process has evolved to handle these gigantic logistical puzzles that, honestly, no human brain could ever solve on its own.
Take the traveling salesman problem. It's a classic in computer science. The question is simple. If you have to visit, say, 20 cities, what's the absolute shortest route you can take that hits every city just once? It sounds easy, right? But the number of possible routes explodes so fast with every new city you add, it becomes mind-bogglingly huge.
And this isn't just some textbook thought experiment. A company like UPS faces this problem every single day. They use a powerful algorithm called Orion to figure it out. And really, Orion is just Euclid's tiling algorithm on steroids. It crunches through a staggering number of possible routes to find the most efficient one, saving millions of miles and tons of fuel. So now that you get the basic logic, right? Input, process, output. You're going to start seeing these algorithms everywhere, working quietly in the background of your life.
I mean, think about it. When you get cash from an ATM, that's an algorithm. Unlocking your phone with your face. Algorithm. The playlist that seems to know you better than you know yourself. The movie recommendations on Netflix. Your social media feed? Yup, all algorithms.
And that's really the key takeaway here. At the end of the day, an algorithm isn't magic. Whether you're tiling a courtyard in ancient Greece or routing a fleet of delivery trucks today, the idea is exactly the same. It's just a set of steps to get from a problem to a solution.
And that leaves us with one last really big question to think about. If these powerful, invisible instructions are shaping our world now, who is shaping the algorithms? They're guiding everything from our commutes to who we date. So as they become even more powerful, you have to ask, who's writing the recipes?